This kind of question. Select a technique that could be used to separate the components of the following mixtures. And we have like 4 different mixtures. First, sand from water, and we have solution made from sand with water. We have potassium chloride from a potassium chloride solution. We have different indicators and universal indicator solution. And we also have a mixture of ethoxyethane. Boiling point is 34 degrees Celsius, and I will definitely talk about why do we need to take into consideration the boiling point here. And also we have 1-hexyloxyhexane, and we also have the chemical formula and boiling point of this hexyloxyhexane. Hexyloxyhexane is the 220 degrees Celsius. So before solving this problem, I would like to highlight different methods. So the first method in order to separate the components is filtration. And during the filtration process, we are separating insoluble solid from a liquid. So this is used in case of insoluble solid from liquid. Now, everyone knows that sand does not dissolve in water. So in this case, sand can be considered as insoluble solid, and simply we can use the filtration technique in order to separate. And now I would like to highlight how does the filtration technique works. So we have Erlenmeyer flask. I'm not good at drawing, so just let me draw it in a different way, so it will be much more easier for you to interpret. Sorry again, but I have to draw it. So I assume that this is the Erlenmeyer flask. We definitely need a cylinder, filtration cylinder. And we need filter paper, right? Here we will have filter paper. So why do we need filter paper? When we're putting something in order to filtrate inside the filtration funnel, unless we have filter paper, all the solid will go down and there is no point behind filtration process, right? So here we will have residue, something that stays on the filter paper, and something that we don't really need in this case, or maybe we will need it, but our purpose is to separate this part. We have filter funnel. This is filter funnel. And here we will have some liquid, and this will be filtrate. So what we are doing is that we have sand and water, and we should take the separation funnel and we should put the filter paper inside the separation funnel and just filter sand from the water. So filtrate in this case will be water, and residue will be the sand that will be left on the filter paper. We have this kind of question: how do we separate potassium chloride from potassium chloride solution, right? Potassium chloride from potassium chloride solution. So we have certain Erlenmeyer flask. Sorry again for my drawing. I have to make it right. And inside that we have potassium chloride, right? And we all know that what is the chemical formula for potassium chloride. So my purpose is to separate this potassium chloride, which is crystal in its natural form, without dissolving into the water. It's just crystal. So how do we separate? In this case, we have to use another separation technique, which is called evaporation. Now I'd like to talk about evaporation. Evaporation is used to remove solvent from a solution. So solvent in this case is potassium chloride itself, and solution is the potassium chloride solution, right? For example, if I heat potassium chloride, and we take this kind of apparatus, and here we have some heating. Some heating source here, and here we're around bottom flask where we put our sample, and this will be the solution, and this is the evaporating dish. We will see that water will start evaporation, right? After it reaches its boiling point, which is 100 degrees Celsius, the water will start boiling, and water will evaporate, and finally we will be left with the crystals of potassium chloride. If we want to have larger crystals, there is a very useful way. We should boil the water, evaporate it, and then let it crystalline, and let it evaporate at room temperature, and then we will have larger crystals in this case. So this is the heating source here. So for the first case, we used in order to separate sand from water, filtration, and in second case we used evaporation. Another example that we need to solve and find out which separation technique we will need is different indicators in universal indicator solution. So let's see. Different indicators in universal indicator solution. What is indicator solution? We have Erlenmeyer flask, right? And here we have solution. And this solution is universal indicator solution. So it means that in this solution, there might be different indicators. For example, indicator A, indicator B, and indicator C. And what is my interest? My interest is to separate A, B, and C from each other. In this case, we will need paper chromatography. Generally, paper chromatography is used to separate the various dyes in colored inks, to separate a mixture of sugars or amino acids, or to test the purity of a substance. So, experimental setup that needs to be taken into consideration is the solvent, and this solvent should be placed in a closed container. Now, this container should be closed, and here we have solvent. This is the solvent, and here we have the paper chromatograph paper, and we need above the solvent 1 centimeter where we put our sample. So this is the place 1 centimeter from the solvent we should put our universal indicator solution. And time by time, because of the capillary action, we will see that different spots will appear. So these spots will then be identified as A, B, and C, depending on the characteristic of A, characteristic of B and C, and also what are their polarity and etc. And also it depends on the solvent as well. But general experimental representation that we see is that whenever we have like universal indicator solution, all indicators represented in the solution might have different interaction based on their characteristic with a certain solvent. We should select solvent and use paper chromatogram in order to separate these separate parts, and then of course it's identifiable. We can identify which part is which, but mainly, for example, if there is 4 or more components, we will have like 4 dots. If there is 5 components inside the universal indicator solution, then we will have 5 spots and etc. So what matters is the setup. This solvent should not have any possibility to leave this part, so it should be closed container, and also we should place it above 1 centimeter of the solvent level. And also what matters is that the way in which we will be able to reveal these spots. Okay, now we have a new problem, the mixture of ethoxyethane and mixture of hexyloxyhexane. And we are also given the temperature, boiling temperature, right? In case of ethoxyethane, the boiling point is 34 degrees Celsius. And sometimes take into consideration that boiling point is denoted with BP, BP. So in case of 1 hexyloxyhexane, we have boiling point 220 degrees Celsius. So whenever we have this kind of situation, 2 solutions, in this case it's ethoxyethane and hexyloxyhexane, we need to use distillation technique. And also the temperature difference, if we subtract 34, we will get 186, which is more than 70 degrees Celsius, right? So whenever temperature difference is more than 70, distillation technique can be used.